let everyone know. Okay, so good afternoon and warmly welcome to our webinar on BIM-based building LCA. This project is part of the Nordic Sustainable Construction Program under the work package on Nordic harmonization of life cycle assessment. I am Rita Lavikka, a research team leader at VTT Technical Research Center of Finland, and I have had the pleasure to coordinate this project. And today our agenda is as follows. First, there will be a short introduction on this Nordic harmonization of life cycle assessment by Maria Tiainen from the Finnish Ministry of the Environment, project owner. Then I will give an overview of the BIM for LCA project and its results. And then we will go deeper into the results by Tytti Bruushyrkäs from Granlund. She will tell you about the process for BIM-based building LCA. And then Tommi Henttinen from Gravikon will tell you about architectural BIM modeling for LCA, specifically about the identification of building elements. And finally, we should have like 30 minutes for discussion and questions. And there is a QR code that you can scan. And I will also later on post this Miro, or maybe Tytti, you could post this Miro link to the chat. So if you have any questions, comments, concerns, whatever, please put it there. And then we can take a look at them later on. Thank you. But now I will give floor to Maria Tiainen.
So welcome to this seminar on my behalf also. My name is Maria Tiainen and I work as a senior specialist at the Ministry of the Environment of Finland. And as said, I am the project owner and leading this project from our part. This is actually the second webinar of this project, and we have had already several other webinars about this whole work package, which can be found on the web page of the Nordic harmonization of LCA. Also, this recording and the materials of this webinar can be found on the website of Nordic Sustainable Construction. Please next. So before we actually start with the webinar, I will shortly say a couple of words of the whole project and who are behind it. So the Nordic Sustainable Construction is a program under the Nordic Council of Ministers, which contributes the Nordic Vision 2030 of becoming a sustainable and integrated region by 2030 in respect to sustainable construction and housing. The purpose of this program is to accelerate the knowledge and capacity for green transition in the Nordic construction sector, also to strengthen Nordic collaboration and ensure an aligned Nordic path. Next, please. The program is organized in the following 5 work packages, working with a specific area of sustainable construction: Nordic harmonization of life cycle assessment, circular business models and procurement, sustainable construction materials and architecture, emission-free construction sites, and then program secretariat and competence for reuse and in construction. And this project belongs to the first work package, Nordic harmonization of life cycle assessment. In Nordic harmonization of life cycle assessment, we work towards harmonizing normative methods for building LCAs in the Nordic countries. Similar approaches will be beneficial and benefit construction industry and policymakers on national and municipal level, so that we can support each other in a Nordic country in a climate ambition in region and in a green public procurement, and also in the European policy development, so to say the EBBD is currently in our interests. So this work package consists of also 5 different tasks, which are the Nordic LCA practices, database and scenarios, digitalization of LCA, and limiting values. And the last is about the acceleration program. So today we are hearing about the task 3. The other work packages, the task 1, 2, and 4, have been finalized, and there are recordings of the webinars and end reports from the website of this project, so please check them out if you're interested. And the final task 5, is currently undergoing. We will have webinars on the acceleration program end of this year and beginning of January, so please stay tuned if you are interested in. In the final slide, I have put together the website where you can find more information or contact the Nordic Sustainable Construction. So enjoy the webinar.
Thank you, Maria. So now we will go to this overview part of this project. So we had 3 project goals: to develop first a generic process for BIM-based building LCA, so how to do that in practice. Then we created a lot of design models, BIM models, for architectural, structural, HVAC, electrical, and also their IFCs. And what is great is that they are all free to use for you. So you are now, after this webinar, free to use them for whatever educational purposes. And we have created a lot of learning material, kind of instructions for you, and also videos which support you in calculating BIM-based building LCA. And Anna-Riitta Kallinen, who is also online, is kind of the main responsible person for those materials. And our focus has been on normative building LCA. And I will first guide you through these building project phases, starting from this conceptual design. Here, the life cycle assessment aims to compare LCA alternatives. And here you have emission data on a rough estimate level on structures and on systems. Then we go to this first normative phase. So this building permit LCA, which is now proposed for Estonia and Iceland. And here it's kind of a first estimation of the LCA. And here you generally have architectural model at the building permit phase. And then when we go deeper into the design, at the technical design phase, you have more designs available. You get a more accurate LCA based on the quantity takeoff. And here you even have like specific environmental product declarations as emission data source. And finally, we get to the second normative phase. So this construction and handover phase, we call it as-built LCA. So here you should have all the information. So how the building is really designed, what materials and products there is. And this is already in Denmark and Norway, and now proposed in Finland, and also in Sweden, and proposed in Finland and Iceland. Our working group, so VTT has been coordinating the project. Granlund and Gravikon has been working on the BIM models and the process. Insinööritoimisto Kallinen regarding the learning materials. And then we had several Nordic partners supporting in our R&D work, collecting data from the various Nordic countries and Estonia. Thank you for the whole working group. We already published our first report in December, and that report lays the foundation for our work that we will also present to you today. This report, you can access it in the Nordic Sustainable Construction website, and it tells about the constraints and enablers for BIM-based building LCA and enablers for harmonization and constraints regarding that. And I will quickly go through those results which have already presented in December webinar. So we look at the status of normative building LCA in the Nordic countries and Estonia, and you can see that all the countries will have, or they already have, a normative building LCA, and also already have or coming these limit values. Then regarding the modules that the various countries have, they are somewhat similar and there are some differences. Almost all countries have this A1 to A5, actually all of them, and then B4 and B6, except for Norway and these C and D. A little bit special case here, but otherwise similar. Then about the phase. So as told, those two normative ones, building permit and as-built. So some have this as-built and some this building permit phase, or even proposed to have it like twice. The floor area differs a bit between some of the countries, how you define the floor area, and what are the accepted emission data sources, and whether you have a conservative emission factor for the general data. So this is an overview, and these slides will be available to you later on, so you can take a deeper look at them. Then a kind of a summary of the constraints and enablers for Nordic harmonization. So as told, there are some differences in what modules are included and also which building parts are included, how you handle the biogenic carbon, and what are the accepted data sources and use of conservative values. Then about the enablers. Well, all the countries have as a starting point the standard EN 15978 and EU levels. And then there should be a process for unified calculation of the building parts, handling BIM material inventory lists, and tracking assumptions. Because currently you make assumptions during the LCA calculation if you miss some data. Then we looked at also the BIM maturity in the countries. So all the countries use these authoring tools, at least for the architectural and structural modeling, which is of course great because BIM allows the export of IFC, the data exchange standard format. Many countries have BIM guidelines for the architectures, maybe also some other designers, but they are rarely used like within all the stakeholders in that country, or they are mandatory. And they don't specifically support this building LCA as a use case. Then the naming conventions and classifications for materials and structures vary, and they are also national, and maturity and usage vary also by country. Then a summary of the constraints and needs for using BIM for building LCA. So one of the constraints is that information content and identification of objects and materials is not standardized. There are some inaccuracies in quantity takeoff. So this is one thing that we have addressed in this project. Some interoperability issues between software and some modeling conventions regarding these spaces, as I mentioned. Then, of course, not all data comes from BIM. For example, this B6, energy use and energy sources. But this is, of course, related more to automation. Regarding the needs, well, the starting point is that these calculation rules, they set the LCA requirements for BIM modeling process, and this information content and identification of materials and structures, it's not standardized, so it should be in the future. Okay, and then we come to the report that is now being launched today. So there's a QR code, so you can access this report. It's called BIM for Building LCA, Enhancing Nordic Sustainable Construction through Digitalisation. And here is a short summary of the results. So we describe the process for BIM-based LCA. So that should support you in your calculation and reporting efforts regarding normative LCA. We have created lots of guidelines for reliable BIM-based material inventory. So like specifications for information needed for modeled building components, how to transfer data from BIM tools to LCA tools, and what is this iterative design and analysis workflow between BIM and LCA. Then we have also envisioned a pathway towards automated BIM-based LCA. So we think there will be automation in the future. And of course, this kind of automation would support kind of feedback loop and finding the low carbon design solutions in the right phases. Then we have designed 2 buildings and their BIMs, as I already told. Lots of models have been created in this project, and they are all free to use for all the practitioners that are working in the field to kind of learn how to do the modeling in the right way in a structured format which supports building LCA. And finally, these educational videos on BIM-based LCA. Here are an illustration of the building designs. Tommy will talk about them more later on, but you can see one of them is a residential building and the other one is an office building, and both have been designed with a wooden and a concrete structure. And we have used ArchiCAD and Revit. So there they are. They take this QR code and download for free. And then my final slide is just a list of the videos that you can also access on YouTube. The first one is an introduction to this project. The second one talks about this process and the building LCA calculation principles. Then we have a focus on architects' building permit and as-built phases. So what is the information content needed there, how to do IFC export. Then the structural designer viewpoint, again, information content, IFC export, Excel import. And then view on HVAC designer, what is the information content needed, and IFC export. And finally, for the LCA experts, how to do IFC export, LCA software import, and an example how to calculate CO2 of a specific structure. Yeah, I hope these are like inspirational results for you. And now I will give the floor to Tytti Bruce Hyrkäs.
All right, thank you. Thank you, Rita, and hi from my point of view as well. So I'm going to be talking about the process for BIM-based LCA, but also a bit about the background. So I'm from my own background an LCA expert, worked a lot with trying to use the building information models to the building LCA, sometimes with success, sometimes with not. And I'm going to open you a bit the background, why this is actually important, why we would benefit from the BIM-based LCA, but also what are the constraints at the moment, why it's not maybe working, and what we can offer here to help to actually reach the automation and help the low carbon steering in construction projects. But yeah, Rita, can you please give the next slide? So just as an overview, what is the main goal here is to enable the whole life carbon assessment in a building, or wider life cycle assessment, where we do take into account more different environmental impacts. But as the climate change is a major issue at the moment, this is where the regulation is aiming at the moment, so that we could actually analyze and steer the whole life carbon emissions of a building. And what does that mean in practice? is that in the calculation, we aim to take into account all of the emissions that occur over the whole life cycle of a construction project. So we use this tool in the design phase to try to analyze what will happen over the whole life cycle, taking into account all the processes that happen from the very beginning of harvesting the construction materials to all the way to the end where we maybe demolish the building. And this means that we will need information about the building products and their emissions over the whole life cycle. We will need information about the transportation, about the construction process. We will need information about what will happen during the use stage of the project. So the energy consumption, how many times we'll have to replace different building materials, which kind of maintenance we need in the building. And at the end also what will happen at the end of life. So can we possibly recycle the materials, or do we have to landfill them, and which kind of impacts that will have. And even in addition to those, we'll have some benefits that are beyond the project scope. So basically, for instance, some of the building materials might be used in another building that is beneficial, but it's not part of this building's life cycle. So we can talk about those impacts as well in the benefits and loads beyond the system boundary, module D. Can you, Rita, push forward? From the information point of view, what does this then actually mean? Is that we will need information about which components we'll have in the building, what are the exact materials and their quantities in those components. So to be able to analyze the emissions of certain material, we'll have to know how much of them we have, which materials we'll have, and then we'll have to be able to link that information to material emissions. This could be done using some generic database, like what is the typical emission of certain strength glass concrete, or we might do it by linking the information to a specific product from certain manufacturer, which is of course way more specific. But on the other hand, if we are in an early stage of a project, that information might not be available yet. And then to be able to include the whole life cycle perspective, we'll also need information about the other life cycle stages. Let's say about the transportation distances, about what will happen on the construction site, about the energy consumption of a building. And now, what is then the role of building information models? Is that they do contain information about the building components. They do contain information about the materials in the components. The specific content will depend on which kind of a model we have. It will depend on which stage of project we are. But as the model has a lot of information we need here to start the life cycle assessment analysis, it is very interesting for us to find ways to use the models for the calculation, because collecting the needed information other way is quite time consuming. It will require manual work. So if we could automate using the models to the LCA calculation, we could make the calculation a lot faster and enable using the resources for better use, such as trying to find the better solutions for the building. Can you read up first next? So steering the emissions, it will require follow-up through the design process. So from the emissions point of view, we will make important decisions that define the emissions of a building, starting from the pre-design and installation phase of the project. And if we want to actually steer the emissions, we will need to follow up those throughout the whole process. We need the whole design group. Architect will have to know how much emissions their choices create, which kind of choices they have. The same applies to the structural designer. We'll have to take it to the purchasing of the building materials to be able to compare different material manufacturers. And then when we go to the legislation and those requirements, they also require us to show the emissions or in most countries, they will require us to show the emissions at the end of the life cycle or at the end of the project in the as-built phase. So steering the project would, if we want to do it on knowledge base, it requires a lot of calculations. And the fact that we need a lot of calculations means that there is also a lot of work involved unless we find ways to automate the process. So this makes the automation from building information models even more important. Next. Then if we look at this from the perspective of availability of the data, depending on in which stage we try to find or steer the emissions, we'll have very different data available. So if we start from the pre-design phase, we probably don't have any models. We'll have just some generic, maybe sizes, some specifications of the building available, or some very rough sketches which don't have material information in them. And then when we go through the design process, the further we go, the more information we'll have available. But on the other hand, the more information we'll have available, the less changes we can apply, at least efficiently. So this comes to the fact that the earlier the stage, the less information we can get from the building information models, and the more assumptions we'll have to do. And in practice, doing the LCA calculation practically always requires using several different sources. It requires using several different models. It requires adding information elsewhere compared to the models. So, for instance, for assumptions, it might be that we need to do assumptions for some materials that are not available yet in the models. We'll have to add in the information related to the whole life cycle. It might be that we'll have architectural model, which has some of the information, but then we don't have design or structural model yet. We don't have HVAC models, so then we'll have to estimate those information. And on the other hand, throughout the design, at least from the LCA expert point of view, we always try to include the whole building to the calculation, because only that allows us to look at the whole thing and where we can do the changes. But so what is important take here is that we'll need different information for the LCA. Some of it is in the model. How much of it we can get from the models depends on the project phase. And it is also maybe good, like what is the current status then? It is good to understand that in some fields there are very nice working automation workflows, but mostly those focus on some specific tools. Those happen inside maybe a specific company, so that there has been possibility to have very strict modeling principles, and we haven't yet seen any solution that would allow us to automate the whole thing, but some parts of it. And of course, we are aiming towards improving the automation, finding more ways to automate, and this is also what this project is about. But it is good to understand that this is not a solution that will solve all, but we'll be able to make improvements throughout the process in different steps. All right, next, please. Here is the overall view of the data flow from the building information model to the LCA. So basically, we start from the building information model phase. We have there some modeling conventions. There is certain project phase. It's a certain type of model. It covers certain things. But from the model to the LCA, we start first with the data extraction. So we try to get the component geometries or the quantity information in some other form. And we also try to extract the model data content so that we're able to understand what the data is. Then there is often a step of data augmentation, like where we check if we take the data from several models, we check if they overlap, we validate the data, we might do some transformations to the data to make it match to the LCA software, where we then add the emission data, we add the assumptions, we add the other life cycle stages, and then the final step will be reporting. And there are also requirements which are different in different Nordic countries to how we will have to report the results, which might mean like which different building elements will have to report separately. And that, of course, also sets requirements to which kind of data we'll have to get from the beginning, because we'll have to be able to separate the elements that are required to be reported separately. Can you please press next? Then here are some of the, maybe in a more detailed level, some of the issues we've found out that currently prevent efficient use of building information models to the LCA data flow. So first, if we start from the building information models, the main issue there is that the way of modeling is not standardized. It depends between those who model. It depends between, or there are differences between companies. There are differences between those who model. It might be that all of the objects are not modeled correctly. Some of them might be modeled and some not. And if there is no information of which of them are modeled, it's practically impossible to use the model, or at least get a reliable result. You'll get a small result and then you don't realize that something is missing. It might be also that the data is recorded in different properties, so which leads to the fact that we don't recognize it correctly. And it also there is a wide variety of naming and typing conventions to the model, which then doesn't allow us to automatically recognize the data, but somebody has to do work in between. And this means that in the data extraction phase, it might be that the takeoff units don't match. It might be that we don't find the data. The quantities are not standardized, or they are not. We can't get like reliable quantities out of it. It also might be that the LCA system boundary is different to the content, so we would need something that is not in the model, but we don't know it. And then when we go to the augmentation phase, there is often no knowledge on the missing information, and there is also difficulties in finding the overlappings between the models. So same, like if we take architecture and structural model, they might have same information, but sometimes it's difficult to find out which of the model information is overlapping. And then if we come into the LCA software with this kind of a data set, it's very difficult to reliably map it to the emission data, which will then produce unreliable results. And then it also might be that at the reporting stage, we report the emissions, for instance, in wrong categories or something, because it's not. It depends on how it's modeled. So there is actually a lot of issues at the moment that prevent us or make it difficult for us to use the models, even though there would be a lot of value in doing so. And if you look at this, a lot of these issues are actually related to the communication, and they're related to the standardization of the systems, how we use the models. But yeah, so this is basically the background, and here is where we have started to try to find solutions how we could make this better and make the models more usable. So the common understanding, it is the success for us to actually, or the key to success for us. So basically, to make this work, what we need common understanding, like information requirements, such as geometries, type designators, so that it's understandable for all of the parties involved in a construction project what is modeled, how it's modeled. And I think as a general, like a general takeoff from this project, a good documentation will help a lot. So we offer here some rules how to do this, and some like guidance which you can use as a basis. But most important thing is that there is a common understanding, there is a common accurate set of rules, and there is a good documentation. What has been modeled, what has been left out, what is the level of detail, which building parts are included and which are not. which properties are employed to store the data, and also where can LCA analyst find supplementary information, because it doesn't have to be so that everything is on the model. We just have to know what is in the model and what's not in the model, and how it is modeled there. Yeah, can you take next? So our solutions here are, maybe you can take them as the first steps to improve this on a like large scale. So we have described a process from BIM to LCA to help in communication and to create common understanding in the project. So which steps are involved, what happens in each of those steps, and like which kind of information needs the LCA side has, so that the modeler has an understanding how the model is used and what we are aiming to do with it to get the LCA or whole life carbon results. And then there are specified general modeling principles and data requirements for certain types of models. Basically, the aim here is to enable that the material inventory lists can be processed more efficiently. We don't need, with this guidance, there will be less need for manual work to make the data work. And maybe one thing to mention, which is not a solution but a restriction to the results, is that the information requirement for calculation of non-material related LCA modules is not likely something that will be included in BIM, and it's also most likely efficient to use from other sources. So therefore, these are not included in this project. You can press one more, or maybe a little bit more, but yeah. So yeah, thank you. This is where I aimed. But so where we are today, what I explained, varying modeling conventions, no common understanding of what is in the model and what is actually needed for the LCA, so that everybody would understand the requirements. And where we aim to take this with this project is to enable material takeoff for LCA. So creating more standardized, better quality material takeoff that would enable life cycle assessment calculation in different stages of the project. But of course, with focus on the normative LCA. But then, of course, this will require next steps, which can be added on top of this. So actually automating the LCA of materials, let's say with automated overlapping detection or with country-specific rules that everybody would model in a certain way. And although next steps can be integrations, and finally we might end up to the full automation. But so in this project we take the first but vital step towards the whole automation. This is the BIM-based building LCA process, and basically where we start with the and this is in more in-depth described in the report of this work package. But so first we'll have some specific software which is used for the modeling, such as Revit, ArchiCAD, and so on. There is a lot of these different software tools, and in the modeling happens there, and those software include certain specifications for properties. What is important that already in the software where the modeling is done, the specifications are taken into account, and there will be added information that is necessary for the life cycle assessment purposes. So the LCA requirements are taken into account when modeling. Then the next step is to transform that information into the IFC. And why we use IFC here is that it is the common format which we use in construction projects to share data. And LCA is not something that is done by certain fields of design, but we actually do need all of the designs to work together. So therefore, IFC would be the format to do the common calculation. And there we will have the data specifications for IFC property sets, so that there is a standardized, at least partially standardized data which is available, which allows us to use the data for the LCA. And this will of course require that the data is exported also on a standard way, where we have definitions here. Then there is some processing. So we will still have this step for the data augmentation, adding additional assumptions. This could be also done in the lifecycle assessment software already. But then the information is added to the lifecycle assessment software, where the emission information is added and the calculation and reporting is normally done. But so this is the basic project process for how to do the LCA based on building information models. This picture will be shown later on from the more technical and specific point of view, but just to explain from the LCA point of view what is required for the IFC model, so that it works for the CO2 calculations or whole life carbon calculations. We need first we need the correct information, or enough information and correct information in the model. So for instance, we'll need class, predefined type, required properties. This information, or adding this information, will allow us to understand what is in the model, to filter the elements, for instance, for the reporting purposes, so that we can map the right elements to the right reporting classes. And then we also recommend to assign a project-specific type designator to different structures. This would mean, for instance, wall type 1 or something, because this allows to better map the information together with other design information, because in most of the cases we don't have all the necessary information in the IFC model. It might not have the product, or if we are in a later stage, it might not have product information. Earlier stage, it might not have all the information about certain structure type. So this allows us to check it together with other design information and, for instance, fill in the missing parts. We need to, from the IFC, we need the quantity information to be able to calculate the LCA. But the right type of a quantity depends also on which stage we are on the modeling. Like if there are specific geometries that allow reliable calculation of the cubic meters of some element or the volumes, then it will work fine. But then if those are not well defined in the model, it might be better to get area of certain things, and then we will fill in the missing parts based on the design information. Or for some elements, it might be that the environmental product declaration data is based on number of items, certain items, and then those can be extracted as pieces. We do have list of recommended units also in the project description, so those can be used to help to find out how like good practices to extract the information. And well, then when the IFC data is transferred to the LCA calculation software, we will add the missing information. We might add some quantities, we might add some missing materials, missing structures, and also the life cycle information. And this is also why it's so important that we can match this to the other design data, because then we can efficiently fill in the blank blank things. And it also, using this kind of a process will end to a result where we don't need to model everything, because it might not be practical to model all of the things in certain design stage, but we can still use the model and the information that is in the model efficiently, and then add the missing parts elsewhere. You can go to the next. So just as a final thing, here is an example of how the things look in the report. But well, we do have lists of, let's say here we have lists of which building elements you should separate in the model, which kind of classifications you should use, which kind of units you can use for the extraction, and then there is a lot of guidance which can be used. And how I see this could be used is to set the building information modeling requirements in a certain project, so that this can be used as a basis for the communication in the project, so that everybody understands what we model here. And of course, you can use some of them and use some like local requirements in addition to those. But I think this will create a good basis, which can be then used how the project sees fit.
Thank you so much, Tytti. This was really nice presentation, and please put your questions and comments to the Miro board if you have anything for Tytti. Yes, and now we will move on to Tommy's part on architectural BIM modeling. Yeah, was there?
Will we take all the questions at the end?
Yes, that was the plan. Yes.
Okay. Good afternoon. It's almost 1 o'clock here in Finland, so I could say good afternoon. From my side, I'm Tomi Henttinen. My background is in architectural design, but I've been working with building information and building information models for more than 2 decades already. So in this project, I was coordinating the design work. Not only for the architectural part, but the whole design work, and also making the specifications, how the things should be in the models, trying to tackle those points and arguments that Tytti brought in her presentation, and I'm probably going to duplicate some of the stuff as well, because those were kind of the things that we would try to solve and try to find solutions in this project. So let's start. The first we have the design team. So we tried to, in this project, even though we were developing totally new buildings, buildings that are not actually going to be built, but we wanted to be as realistic as possible. So we formed a design team. The architectural design architect of Office Huvila Oy was responsible for the architectural design. Gravikon Oy, which my company, we were responsible for the structural design as well as BIM specifications and coordination. And then we had Granlund Oy, the company where Tytti comes from. They were responsible for the HVAC and electrical design. Today I'm going to talk more or less about the architectural design, but most of the stuff applies also to other design disciplines. Next, yes. So the design principles. So this was kind of, as I said, we tried to simulate kind of a real life project. So we had real life design objectives to emphasize the life cycle properties of the building. So it was not only technical implementation. So there was a idea to have an adaptability. So it's flexible changing of the spatial spaces and rooms during the life cycle. So that, of course, reflects to design alternatives and design options. There was also it was considered the multi-purpose usability, so that the office could be used later as or part of the office can be used as a apartments or something like that, or for other purposes. Of course, access to natural light, so which means that there's no need for full-time lighting in the buildings, and then the bottom line, the design work, we followed the Finnish construction and building codes. We also simulated the building design process. So we had, like I said, several design disciplines, and within those disciplines, we had the typical designer roles. We used BIM-based collaboration, so all design work that was done using BIM models. We concentrated on information content in 2 phases of the project lifecycle, building permit and handover. So we had kind of a real focus in the regulatory process, not that much in the other phases like construction or early design stages. So we were focusing on those 2 regulatory processes, project phases in the project. And then finally, we had 2 types of models. So we were using, for the design work, of course, we were using the authoring tools, Revit and ArchiCAD, and they had their own proprietary file formats. But IFC4 was the primary output format, and that format was then used for data validation and then later on for LCA calculations. Next. So we had 2 buildings. Next one, you can take that as well. Yes. So we had a residential building with the ground floor, with service spaces, and then 3 floors with apartments. So quite small small apartment building. There was a basement with the storage spaces, a garage, a small garage. 1 staircase with a lift, and the ventilation was apartment-specific ventilation system, so there were no additional or separate ventilation room. The office building, that was much larger, so there was a ground floor with the restaurant and some other public facilities, and then 3 floors with office space. The basement also had a civil defense shelter, employee facilities, and some storage space. There was a separate integrated garage building, 2 staircases, and then on the top floor there was a semi-public sauna that can be rented out, and a roof terrace, plus a technical room for ventilation machines. Both of these buildings also were located in a real site, which was given by the city of Järvenpää here in Finland. Next, please. Besides 2 buildings, we had 2 material solutions for the frame. So we had wooden structure and concrete structure. In the residential building, there were load-bearing timber-framed walls with wood-paneled facades. The concrete was more kind of quite traditional load-bearing concrete walls and brickwork facades. In the office building, it was a wooden column and beam structure with wooden paneled facades and a concrete column beam structure with siding panels facades. Next, the material frame, of course, influenced in distances between the floors. So the floor heights were different because of the different structural dimensions. Also, some other dimensions. There were some variations in dimensions because maybe the wall needs to be in wooden structure. The wall needs to be different size than in the concrete structure. Among other things, also we also considered the regulations such as sound and fire performance. So the wooden buildings were applied with sprinkler systems, and that of course caused some extra need for collaboration and clash checking. Next. And then finally, two phases. Like I said, we had the building permit stage and then handover the as-built with the as-built model. So in the building permit, the material information and the product information was more generic. It was more like requirements for the materials that need to be used in the construction. And then in the handover, we simulated the real life situation where we know the actual materials. In this case, this handover stage, the information was produced mainly by the architect, but in real life that would be something that the contractor develops and collects that information based on the actual outcome. Next. So altogether, just to summarize, we had lots of models. As you can see, we had 16 IFC models for the architectural part alone. And besides the 16 IFC models, we had also, of course, the proprietary model file format models for ArchiCAD and Revit. And then in addition, we had the structural, HVAC, and electrical models. So all in all, we had a quite big number of models. And all of these models, like said earlier, all these models are available to all of you in IFC format, plus also in the native proprietary file format. So you can go and download the Revit and ArchiCAD models as well. Next. This is the image that Tytti already showed. I'm going to dig in a little bit deeper how this works. So this is basically one of the key findings in this project, that all entities in the model should contain a type designator. So basically this is a very typical case already today. So if we go to any project we have for the walls or windows or doors, we have those project specific type designators. Now in this project we extended that all components, including electric appliances such as refrigerators, they should also have this type of project-specific designator. With this designator, you can link the information from the model. So the model is more like a map. It's like a navigator, and then the information about the items such as electric appliances or walls or suspended ceilings, they can be either in the model or in the in a additional database, especially when we go to the construction stage where the information about the products and materials comes from the contractor. Then in most cases they don't have access to the model at all. So then with this system, they can collect the information and maintain the material and product information in their own database or spreadsheet or whatever. And then through these type designators, they can be still linked to the model. when those two pieces of information, so the model and then the material and product data, then will be brought into LCA calculation process. In ideal world, the material and product data should be in machine readable format so that we can actually automate this. The format can be IFC, of course, so it could be included maybe in the IFC model, or maybe it's a separate piece of in a separate IFC file. But anyway, we need to find some kind of machine readable format for this if we want to automate the data flow. Next, please. We also, with the project, like Tytti already mentioned, the EN 15978 is kind of that's the initial data, or that's the kind of the standard that specifies how the LCA calculation should be done, and it also presents a breakdown structure for components. So with this project, we made a mapping between the 15978 and IFC. And if you take the next one, also with local classification systems such as CoClass and Talo 2000 from Finland. And this exercise showed that the breakdown structure is pretty similar with these, even though they vary a little bit, but all these like classification system, or let's say most of the classification systems can be linked or mapped to 15978, and also IFC. Which is not a classification system, of course, but it's a system of classes, can be mapped to 15978 standard. So therefore, one of the findings in this project is that actually the EN 15978 could be used as a base breakdown structure for the components, and then the models should be then mapped or linked to that structure. Next one, please. Yeah, like Tytti said, I'm duplicating a lot of her talks. Like Tytti said, one of the key things also was the findings or things that we find in this project is that you need to document what you do. In Finland, we have long been using a document called BIM specification document, which is kind of a document that explains what is modeled, what is the maturity of the model that was delivered, or and what information it contains, what information it doesn't contain, what is the level of information, and so what are the naming conventions that are being used, what are the classifications being used. So it's in short, it's quite it's a thick, let's say it's a short document, but it contains a lot of information, and that should be also maintained together with the model. So every time you publish a model, you should look that and check that the BIM specification document is up to date. Next, please. So the data validation is based on these documents. So for example, in BIM coordination, when we start validating the model, first thing is that we read the BIM specification document, which explains what kind of model we are talking about. In the BIM validation, what we do, we first of all, we check the modeling standards. So are the working methods being are they proper? Has the proper working methods been used? So compliance with BIM requirements. In Finland, we have common BIM requirements dating to 2012. The correct use of entities, so wall should be modeled as IFC wall, not as IFC slab. And then, of course, how can you group the entities according to EN 15978? So all these kind of checks that the working method has been correct. And then the second thing is to check the technical correctness. So is the IFC used properly? So IFC type entities, all instances in the model, so IFC wall should have also IFC wall type. IFC doors should have IFC door type, and so on. So do we have these type entities for all entities? And this was also part of the reason why we use two different authoring tools, because we want to check that both of these tools, Revit and ArchiCAD, can provide these structures. Then predefined types, the IFC wall partitioning, for example, for walls which are separating spaces and so on. These are standard IFC technical. And again, we checked that both Revit and ArchiCAD can provide this information. And then finally, standard IFC property sets and properties. So in this case, we didn't use any local, for the architectural model that is, we didn't use any local property sets or specifications within the IFC. So we strictly used the standard IFC definitions. So based on when the model is correct, then of course everything is easy. So based on the correctly constructed models, we can have the IFC geometry, IFC class, and predefined types, and project design designated types. It's easy to filter, like you see the images below here in this slide. We have to remember that the IFC model contains only the information about the designed entities, so it excludes waste, temporary structures, and so on. The material and product data provided by the architect, it should be based on the project designated types, and the types should be used in the IFC model, of course. The information should be in machine-readable format, but not necessarily within the IFC model. So it could be a separate database or data set. And finally, IFC. Why IFC? Why not a proprietary file format? Why not an ArchiCAD or Revit? IFC enables a standardized data collection process. So if we want to, in large scale, if we want to automate things, we need to have the data always in the same data format. And this is what we can do with IFC. So regardless of the tool that you are using for the design work, the output is always the same. And this kind of means that the data transfer processes can be automated when the source data is always in the same format. Next. So just to summarize, and this is basically the duplicating the process that Tytti already showed. So we have the native model, can be modeled using any tool that can provide IFC output. Then we have the material and product data, which can be within the model, or it can be a additional data set. Both of those, the material and product data and the IFC is then provided to the LCA calculator, who processes this data, analyzes them, and then finally links that to LCA calculation. then of course, like Tytti said, this is just this is not containing all the information. Then you need to add all other information needed for the LCA calculation. And next one, please.
Yes, thank you so much, Tommy. So also this technical part was really critical, and I hope it was also inspirational for all the listeners here. And now the idea is that we would go through your questions in the Miro. I will check if we have any in the chat as well. You can take this QR code also, and let's see what we have. Okay, we already have some questions in the chat. Should we start from there? So Martin is asking, machine readable data for construction object can be the data template approach. Okay, maybe Tommy, if you could answer that. You have already liked it.
Oh yeah, this is a topic, and we have been discussing this with Martin earlier, and definitely we need to find some kind of machine readable format, and definitely these what Martin is pointing out, that they are kind of providing this. What I see a challenge is that most of the people or actors in construction industry, they are not standard oriented. So how do we make a simplified version? And of course we probably need some kind of tools, software tools, but also in this project, in BIM for LCA project, we generated a proof of concept. So we generated a Excel spreadsheet, which was then turned to XML and then back to Excel again. So kind of a round trip, just to make just to kind of to see that is it possible to create a machine readable Excel or spreadsheet, because spreadsheet is not it's not necessarily machine readable, because people can modify it quite freely. So then it can become a chaos. But yeah, this is something that we need to solve, and there are a couple of optional things that we, like Martin pointed out here, that we need to check.
Yeah, there's also at the longer comment here. Maybe Tommy, this is probably also for you. Software concept. Are you familiar with this software?
No.
Okay, maybe we'll take a look at that. But this is totally something different. So without the model.
Yeah, I suppose it's well, it's an option for software, but we do have on the market similar approaches where you can start without the model, and I think that it's actually the most practical way to do it. Or when you are in a very quite early stage, you might have a model which does have geometry of the building but doesn't contain any of the information of the material or structures. So then at that point you could just use the sketch from the geometry to produce the calculations, and then it of course requires adding more information in a software. But yeah, we do have so early stage that we don't have anything, and then the information will be added along the way on the project. So the approach proposed here makes sense to me.
Yes, thank you. So let's start from here. This was for the first part. So someone is asking, are these IFC models free to use for advertising? And I will put here the Creative Commons license, so you can take a deeper look at it. But yes, but you have to acknowledge the source. But here is the license. You can take a look at that. Then let's take this one. Are we now mainly focusing on projected results? How do we get actual as-built LCA reports if they are based on best? Oh, yeah, this is a really good question. Maybe Tytti can answer this.
Well, we do get the results we get depend on the data we get to the calculations. So if we have as-built information in models, then we'll get an as-built calculation in LCA, and if we don't, then we don't get. So I think it totally depends on the project data, and of course, if we then look at the life cycle and steering the emissions throughout the life cycle, we should also use or sort of continue following the emissions throughout the building life cycle. It might be done by following up the energy consumption. It might be done by calculating the renovations, following up the renovation emissions, and so on. So that's of course something you can only do during the use stage of the building. But that is also something that is part of the organization level carbon emission calculations, for instance, based on CSRD, like corporate social responsibility reporting standard.
Yeah, but we do like this comment. We agree that we should add all this information. Currently, we don't have that much information from the construction side, so we hope this will be the future. Then, how can we control the maturity of the BIM model used as basis for the LCA calculation? And this is also a really good question. Maybe Tommy, do you have experience? How do you make sure that you have the building permit model and then the as-built model? How do you do that?
Well, the short answer is that we cannot control it, but the longer answer is that we have, like in this project, we have two stages or two phases of the life cycle in the implementation phase of the so we have the building permit stage, and then we have the handover. Those are regulated, at least here in Finland. Those are the two points of the project where we have where there is regulations. And in Finland, for example, we have at the moment ongoing legislation which is going to specify the content of the models within those two stages. So those kind of I think that those are the stages where we can actually control the maturity, but outside of those two regulated points, I think that we are not so good. We don't have too many ways to do it.
Yeah, but from like LCA point of view, I really hope that we would find processes to control this on a project level. It can be something that is agreed on a project level, and I think there are different tools to use it, but just the important thing is that it is somehow considered during the design process, and there is like discussion and common understanding about it.
Yeah.
Maria,
thank you.
Maria has her hand up.
Okay, perfect.
Yeah, I just wanted to add or say something about the regulation regarding the climate declaration. So in Finland, climate declaration needs to be done in the as-built phase and not in the build design phase. So just to make sure that everyone understand this. So I wanted to just add.
Yes. Yeah, but just to add that the maturity of because the question was the maturity of the BIM model. So for the building permit, the new legislation or the new secondary legislation will actually specify quite detailed what is going to be what is needed to be included in the model. So within in that stage we actually know what is in the model.
Yes.
Yeah. Thank you. Then there's a question on this mapping exercise, and yes, it has been done via Excel, and all that material is also downloadable on the website, so you can take a look at that and maybe further develop it. Then there's another kind of easier question. How have the designators been implemented? And yes, we have used IFC classification. Do you want to add something, Tommy?
No, we don't. In this case, we didn't use IFC classification, and there's a little bit different. The classification, it's a little bit different things, because classification is a grouping thing. I'm not sure how deep I'm willing to go into this, but the designator and the type codes, they are different. So they are. There's a difference between those, and the designator is a project-specific type. For example, wall type 1 or wall type 2, whereas classification groups things. So we know that these are light-bearing partition walls, or these are compartment walls, or whatever. So classification does a little bit different things than the IFC, the designators in the type designators in IFC models. So they have different roles. We need them both, but yeah, they have a little bit different roles.
But from the LCA point of view, the type designator is like, I think in some cases it is included in the current models, but from my experience, in many cases also it's not. And like for us, for validating the data, for enhancing the data with additional things which might not be modeled, or checking the data if it makes sense with the other design data, actually adding this one would be a huge step towards being able to trust the data and also be able to find possible missing parts, and also to add, let's say, often the design descriptions might have more specific information about certain products than the model does. So adding this to the model will allow us to add a lot of information and also improve being able to trust the information we get.
Okay, and then there's a more technical question. I'm not sure if this is for Solibri.
I can answer that. The question is about the apartment building IFC, and then about all these properties. Like explained earlier, the only thing that is relevant in the models is the type, and that's why because they are, depending on the tool that you use, the authoring tool, and depending on how you have modeled, depending on what is the kind of the handwriting, or how do you call it, what is how the architect has done it. It depends. There are variations in this, how the materials are in the models. So in this project, we actually didn't focus at all putting in the material information in the models. So the material information, it's basically the material information that you can find in the models is actually something that the application or the authoring tool is providing you automatically or semi-automatically. We only focused in having the types. So we have the wall type 1, wall type 2, etc. And then we have additional, in this case, spreadsheet, which explains what those materials actually are.
And those spreadsheets, they are also available. So just please download and take a look at them. Yes, thank you so much for these questions. I think we have now covered them all. Do we have some more in the chat? I guess no. But I guess Tomi and Tytti, I think you are still available to, if someone wants to contact you and ask some specific questions. And
Yes.
yes, and all the models, videos, report, they are available online. So please
And
take
just
a look.
maybe a disclaimer about the models, as I said, we produced quite many models, and they are not flawless. They are you can find errors, so they were more like used for proof of concept, that we tried to find the methods and processes and ways to do it. So if you run a like a comprehensive check with Solibri, I'm sure that you find lots of errors, but that's not the point in this case. And you are, like I said, those are available for you, so you are free to develop them further.
Yes. Thank you for all the questions. Is there anything else that you would still like to go through? Otherwise, I think we have spent the time, and it's maybe coffee break time, at least in Finland. Maria, do you still want to say something?
Well, just thank you for the big project, and hopefully people can find the resources that you have produced during this project.
Yes, thank you. We also really would like everyone to take the models. It's exceptional to have these proprietary models available. So please, if you are in any educational organization or anywhere, please just take them and start using. Morten, do you wish to say something? No, okay.
I just want to thank you very much for this webinar. It's been very informative.
Okay, really nice to hear. Thank you so much. Okay, but then I will wish you a really nice rest of the day, and please take a look at the results and start using them. I think this is the start for a better information capture and use for the whole building life cycle. Yes, thank you so much. Bye-bye.
Thank you. Bye.
Good afternoon. Bye-bye.
Thanks, bye.